PIC microcontroller. PIC is a family of Harvard architecture microcontrollers made by microchip technology derived from the PIC 1640, originally developed by General Instrument Microelectronics Division. The name PIC initially referred to Programmable Interface Controller. PICs are popular with both industrial developers and hobbyists alike due to their low cost, wide availability, large user base, extensive collection of application nodes, availability of low cost or free development tools, and serial programming capability. Core architecture. The PIC architecture is distinctively minimalist. It is characterized by the following features: separate code and data spaces, a small number of fixed length instructions, most instructions are single cycle execution with single delay cycle upon branches and skips, a single accumulator, the use of which is implied. All RAM location functions as registers as both source and or destination of match and other functions. A hardware stack for storing return addresses. A fairly small amount of addressable data space extended through banking. Data space mapped CPU, port and peripheral registers. The program counter is also mapped into the data space and writable. Unlike most other CPUs, there is no distinctions between memory space and register space because the RAM serves the job of both memory and registers, and the RAM is usually just referred to as the register files or simply as the registers. This is the core architecture of microcontroller. Data space. PICs have a set of registers that function as general purpose RAM. Special purpose control registers for on-chip hardware resources are also mapped into the data space. The addressability of memory varies depending on device series, and all PIC devices have some banking mechanism to extend the address into additional memory. Later series of devices features move instructions which can over the whole addressable space, independent of the selected bank. In earlier devices, any registers move had to be achieved via the accumulator. To implement indirect addressing, a file selecting register and indirect register are used. A register number is written to the FSR, after which read from or write to INDF will actually be to O from the register pointed to by FSR. Later devices extended this concept with post and pre-increment decrement for greater efficiency in accessing sequentially stored data. This also allowed FSR to be treated almost like a stack pointer. External data memory is not directly addressable except in some high pin counter PIC 18 devices. Architecture, Harvard architecture. Computers use the von Neumann architecture, but PIC microcontrollers use the Harvard architecture, which incorporates separate program and data memory. Code space. All PICs features Harvard architecture, so the code space and the data space are separate. PIC code space is generally implemented as EPROM, ROM or flash ROM. In general, external code memory is not directly addressable due to the lack of an external memory interface. The exceptions are PIC 17 and select high pin counter PIC 18 devices. Word size. The word size of PICs can be source of confusion. All PICs handle data in 8-bit chunks, so they should be called 8-bit microcontrollers. However, the unit of addressability of the code space is not generally the same as the data space. For example, PICs in the baseline and mid-range families have program memory addressable in the same word size as the instruction with 12 or 14-bit respectively. In contrast, in the PIC 18 series, the program memory is addressed in 8-bit increments, which differ from the instruction width of 16 bits. In order to be clear, the program memory capacity is usually stated in number of instructions rather than in bytes. Stacks. PICs have a hardware called stack, which is used to save return addresses. The hardware stack is not software accessible on earlier devices, but this changed with the 18 series devices. Hardware support for a general purpose parameter stack was lacking in earlier series, but this greatly improved in the 18 series, making the 18 series architecture more friendly to high-level language compilers. Instruction set. A PIC's instructions vary from about 35 instructions for the low-end PICs to over 80 instructions for the high-end PICs. The instruction set includes instructions to perform a variety of operations on registers directly, the accumulator and the literal constants or the accumulator and the register, as well as for conditional execution and program branching. Some operations such as bit setting and testing can be performed on any numbered register, but bi-operand arithmetic operation always involve W. Writing the result back to either W or the other operand register. To load a constant, it is necessary to load into W before it can be moved into another register. On the older course, all register mode needed to pass through W, but this changed on the high-end course.